All right. Okay. Can everybody hear me? Just drop a GM in the chat. Let me know if you can hear me. Let me ask as well. Get some tunes going. Oh, hear me even. Let's get some of these tunes going. All right. Please let me know if you guys can hear me, because that's the only way we're going to be able to move forward, right? Awesome. All right. Hey guys, hey everybody. Where's everyone from? Tell me where you're from. Drop it in the chat. Tell me where you're from. Tell me what time it is. I'm from Melbourne, Australia. It's 8 in the morning here, so it genuinely is a GM moment here. But I know a lot of you it's evening and late at night, so let me know in the chat where you guys are. Excellent, Ecuador. GM indeed. Where's everyone else from? Abidan, Rochia, where are you guys from? Somewhere along the East Coast, USA? Sweet. Excellent. Excellent. East Coast, so it's evening. You got people from Michigan. Awesome. Seattle, West Coast. Nice. I was in New York just a couple of weeks ago, actually, for SmartCon 2022, our first live in-person event. Did any of you happen to be there by any chance? If you did attend SmartCon either virtually or in person, let me know in the chat. And we will get started in about a minute or so, guys. Got quite a bit to cover today, so it's gonna be a bit of fun. Oh, cool! You were at the Hack House. Sweet. Nice. I love the song. This is Bill Withers' "Lovely Day." Always gets me going. Like it's just a great way to start a day, great way to start anything, an event. Like it's just so good because people know it. It's got lots of energy. It's a positive song. It's a beautiful song. Ooh, Zach just woke up at 5 p.m. I like it. I like it. The city that never sleeps. I know. I was there just last week, man. It was wild. I spent way too much time at Katz's Deli. I got to tell you, wait, too many pastrami and rice sandwiches. Way too many. It was really good. All right, wonderful. Bolivia, nice, very nice. Are you in the same Abidan? Are you in the same time zone as the west coast of the U.S. in Bolivia? Just let me know in the chat. Oh, cool, Zach. You were at SmartCon too. Awesome. That's great, man. That's great. And just want to check, you guys can see my screen as well. You can see that it says the Fall 22 Hackathon, building and using external adapters. I can see it, but I want to make sure that it can be a little bit laggy at times. So I just want to make sure that you guys can see it okay. Hey, Primo, Nigeria. Nice, 10 p.m. Rahul, namaste. Welcome. Hi. Welcome from India. Awesome. Excellent. All right. All right. Let's maybe get started because we're 3 minutes over. Music ad. Time to get in a code zone. All right, guys, welcome to the 22 Fall 22 Hackathon. Really glad that some of you could join us here. So today I'm going to be talking to you about external adapters. So I'll take you through what that is in a moment. By all means, code along. In a moment I'll talk to you about who this is really for. I'll trying to keep an eye on the chat, but if I miss your message, I'll try and pause at regular sort of segments and just paste your question in again. I'll put it up on the screen, and then we can I can try and answer them, and we'll go through. Now this may move some kind of fast for some people. It's very hard to know what people's levels are. Don't worry about it. I'll tell you what you need in case it's moving a bit too fast for you. Plus, this is being live streamed now, but it will be recorded and available on YouTube, so you can always come back later and we can do this. All right, so let's get started. So as we talked about, building and using external adapters, this is how we access off-chain data, do some heavy compute, and I'll show you all that in a moment. A little bit about myself. My name is Zubin Pratap. I'm a developer advocate and engineer at Chainlink Labs. Before that, I was a software engineer at Google for a couple of years. And before that, believe it or not, I was a corporate lawyer of all things for for like 15 years. Yeah, done all sorts of things. By far and away, engineering best. Totally red, right? Really, really great. Okay, now a couple of things you need for this demo. You need some girly ETH. And you need to, well, you don't really need the girly ETH. That's not entirely true. It may be useful though, so just have some girly link. You definitely need that. You can get it at the link at the bottom. You can see faucets.chain.link. That's where you go and get it. Try and get it now while you're listening if you can, because the transaction takes a couple of seconds and all that. People who've got some programming experience will probably benefit the most from this. Having said that, what do we mean by some programming experience? I'd say about 3 to 4 months. With basic JavaScript, I think you'll be okay to follow along. Some of it may be a little bit complicated, but I'll do my best to explain that to you. Now, any background in Node.js, TypeScript, and Solidity would be even better, and ideally you have all that environment set up. If you understand what a Chainlink node is, that's probably really, really good. Let me see if I can give you the link. So one of my colleagues, Patrick, I think ran the workshop earlier today that talked about this link. So I'm gonna put this here for you guys. So that's the link for how to. That's the link for running a Chainlink node locally. Yeah, that's definitely the link. And so if you haven't done that before, you're not going to be able to use the adapter without having a node running locally. So follow along on that. Oops, sorry. You'll definitely need one locally. Now, if you worked with Chainlink's NE API or direct request, a lot of this will be familiar for you. So that's probably a good way to go. I'll tell you where it is in the docs as well. And of course, you'll need an IDE with Node.js, Yarn, and NPM running on it, right? And a terminal application. For those of you on Windows, you'll probably need the WSL, the Windows subsystem for Linux, if to run some commands and stuff like that. But I'm sure you're probably familiar with that already if you're here for this talk. Cool. Yes, thank you. That's exactly right. That's faucets.chain.link is where you can get. It's on the screen as well. Is where you can get your girly link and a little bit of ETH if you end up needing that. Though I'm not sure you will. Okay, so very quick overview, guys, and a recap of how Chainlink nodes fetch external data and then submit them on chain. So this is the concept that underpins Chainlink NE API. The idea is, as you know, smart contracts cannot really connect with external data, and compute can be quite expensive on chain. And so you can use things like NE API and the Chainlink Oracle network, especially our decentralized oracles, to access external data like any arbitrary API, pull that data in, do some compute on that, and then submit that onto the chain. Okay, so you're doing both the data fetching for any arbitrary data, and you're also doing some processing or compute, whatever you want to call it, off-chain to save some transaction and gas costs, and then you submit that on-chain. Okay, so that's how you connect smart contracts, which are otherwise sort of in this locked-up box, with the rest of the world and actually interact with the other world. And you can send data that way as well. So down there at the bottom of the screen is the at the bottom of the screen being not the YouTube stream. Let me, it's docs.chain.link/docs NE API introduction, right? That link, that's the one that talks about NE API. So it's probably a good idea to know what that's all about. There's a basic request and response model. So your smart contract will send a request via an Oracle smart contract that ends up hitting an Oracle node, a Chainlink node that's technically off-chain, but constantly listening to stuff on the chain, and then that processes and sends back the response via an Oracle smart contract, also known as an operator smart contract. And I'll show you the architecture in a moment, but this is just a very high-level overview. Okay. Now, external adapters. For those of you who are familiar with the adapter pattern in software engineering, really the TLDR is an adapter is something that takes data, transform it into another shape that something else needs in order to consume it. It's kind of like the adapters we have, for power adapters, or when we're traveling countries and we need an adapter for different countries for the wall socket, right? It's kind of like that. Like it has one interface on one side and another interface on the other side. And that's really what a data adapter does, is it converts some sort of data, it adapts data for another shape to use somewhere else. Now, Chainlink oracles, like I mentioned, integrate with any external API. And how it does that is, there are external adapters. So the Chainlink node has a bunch of inbuilt tasks in it. And then there are external adapters. External adapters are sort of like tasks, but they're custom tasks. Okay, so the Chainlink node the node software, which you can pull down from GitHub at smart contract slash Chainlink. That's the repo for nodes that has built-in tasks. And then if you want to extend that functionality, we use external adapters, right? Now, why are flexible, why external adapters kind of cool? Well, they allow you to connect to any APIs that aren't reachable via the standard HTTP task. They allow you to implement a standardized API where you get to structure the input and output using the JSON that you want. There is some amount of prescription, and we'll cover that when we talk about the inputs and outputs, but basically you can kind of standardize how the data looks going in and how the data looks coming out, and then within that you can kind of have arbitrary data. Adapters can be written in any language. Today we'll be doing it in JavaScript, TypeScript, but you can do it in Go, you can do it in Python, whatever you like, right? It can be run on the same machine. So what that really means is if you're running a Chainlink node, you can run your adapters server API on the same machine, not in the same process, but on the same machine. And so you can do that to extend your node to have it do things, but you can also run it on separate machines. So you just connect via URL, via regular HTTP, and that means that by having it on another machine means you now can actually run your external adapters as a cloud function or a serverless function, a Lambda function, as some people call it. So whether you're using AWS Lambda or Google Cloud, or Azure Cloud Functions, you can have your external adapter sitting as a function that executes somewhere else on a cold start server, and your node can be on another machine altogether. Your Chainlink node can be on another machine. Right, so external adapters, this is kind of how it looks like, and then we'll go into a slightly deeper architectural diagram. But as you can see, you start from the right side. There's, your smart contract is running on some blockchain. Like I mentioned, there's an Oracle contract that is associated with Chainlink nodes. That Oracle contract is the one you make the request to. So moving from right to left, you make that request. That goes into the Chainlink node. The Chainlink node then connects with the adapter that it has registered on the node, and I'll show you how to do that. And then that adapter goes and fetches the data, brings it back, and sends it all the way back through the chain again to the right. Yep. So why would you want to use an external adapter? Yeah, thank you, Dab. So that's right. That is an external adapter JS sort of template that Dab suggested in the chat. I'm going to give you a simplified version because that template can be quite complex. It has advanced stuff, but I'll show you all that in a moment as well. I'll talk you through that. So thank you for that, Dab. And here's the documentation for external adapters. Man, I appreciate it, Dab. You're making my job so much easier. You're rad, dude. Thank you. That's awesome. Right. So why use external adapters? Well, when you want to do some computation that's expensive, not feasible, not ideal to do on chain, it's a great time to use it. When you're the built-in HTTP task that comes with the Chainlink node isn't quite suitable, you need to customize it, you need to do other things. That's when you'd want to use an external adapter. You also would want to use it when you want custom functionality done as part of the API call. For example, some APIs, you need to add authorization headers, and you may not find the right adapter to do that already on the marketplace. We'll talk about the marketplace at the end. So you may want to write your own adapter to do that, special funky stuff there, right? And then there's also privacy reasons why you may want to use an adapter. Okay, now let's talk about the architecture and data structures, right? And then we'll get to coding shortly. I am watching the clock. Okay, quick sip of tea to moisten the throat. Excellent. Like I said, we're doing this right to left, okay? And at the bottom of the screen there, guys, GitHub, that's the, let me actually paste that in for you here in the chat. This is the repo that we're going to be, that I've created as a starting point for you guys. Okay, so let me pin that up on the screen. If you go there, it looks like this. I've put out a README for you guys, and I've put out a bunch of details. We're going to talk about some of this stuff. You'll see this architecture diagram is the same as what we've got here. So it's all helpfully there. What I'd suggest you do is, we're going to do this in a moment, clone it. But we're going to clone, just so you know, there are 3 branches. We're going to start with start here. At the end of this hour, we're going to have the equivalent of what's in branch 2. I've just put it there in a separate branch for those who weren't able to quite code along or need to refer later on. And then 3, the advanced EA server, is the same one, or is based off of the template that Darb had put in the chat a short while ago, the external-adapter .-js one, right? So I've even referred to all of that here. But yeah, for now we'll start with a simpler version, so it's easier for you guys to follow along, because I don't want you to worry about the code logic so much. I want you to get the mental models down of how an adapter sits near a Chainlink node and how it interacts with smart contracts. And this architecture that we've got on the screen, I really want you to understand that, because that will make it less confusing. You can always make the code sexier, cooler, more complicated, more sophisticated, but it's really important to get how this flow works, right? So we start on the right. Well, we'll end up starting with the external adapter, which is the second from the left, this one here. I know there can be a lag sometimes in the live stream, guys, so I'm going to try and verbalize rather than point. But what we need to do is we need to have a client's consumer smart contract, and we can, that's included in that repo, but I can show you where in the docs you can get it, and there's a little bit of touching up you need to do to that. That will then speak to an Oracle operator / operator contract. The Oracle/operator contract is the one that I said is very closely associated with the Chainlink node. So if you watched that previous live stream by Patrick or one of the other talks and spinning up your own node locally, you'll see that the Chainlink node and the Oracle contract are sort of tightly coupled. Okay, they kind of go together, because each job that runs on a Chainlink node will sort of end up having its own contract associated with it, and you'll see again in about 30 minutes why that is. So we do the client contract. We have to find out what the Oracle operator contract is. I've got one running for the purposes of this demo. That then our request gets routed from our client contract on the right over to the Oracle/operator contract, which then triggers the correct job. There's a task runner on the Chainlink node that's keeping an eye for all things coming out of this operator contract. That triggers the job. We specify the nature of the job, and we do that in this language called TOML. Not the prettiest language, but I'll walk you through it. It's pretty powerful for what it can do, and it's very config-y heavy. So that TOML job picks up the request. It then speaks to our adapter, and it sends that in the form of a structured input, which we'll talk about in a moment. The external adapter goes and gets the data, comes back, does its magic, transforms that magic data into the form that we describe and require in the structured data output that we want from the external adapter. That data gets read by the TOML job. It gets parsed, right? Gets parsed, gets encoded, ETH ABI encoded, converted bytes, and then posted back into the blockchain, and then eventually it comes back to our callback. And I'll show you this entire flow when we do our code along. Okay. Now, requesting data. A couple of things to know. The external inputs, the external adapter gets some input, right? That input will end up kind of coming from the node. Okay. So the node ends up taking the information we send from the client contract, the request, and converts it into a structured format that goes into the adapter, right? That structured format ends up looking like this. Everything's kind of optional except for the data field. The data field will be present. It's guaranteed to be there, but it may be an empty object. Okay. So, there are a variety of use cases where you may need that, where you're just doing a simple GET request, for example. You may just need that. But the data stuff is where we'll end up having structured data. Now, the data returned from the external adapter back to the node, right, will have a data object again, and that's guaranteed to be there unless there's an error, and we'll talk about an error in a moment. And it may have a job run ID. Job run IDs are kind of useful because you can use the ID basically to trace the flow of the request all the way through the architecture, right, through the 4 or 5 pieces of the architecture. So I tend to have them. Now, if there's an error, you don't have to return the data object. You can just return an error field, with something that was in it, and you'll have to handle that appropriately. There is a circumstance where you will ask for data. The external adapter is going to go off and do a long-running operation, an LRO, highly asynchronous task. And so what it can do is it says, hey, I'm doing my thinking. I'm going to tell the node, your request is in a pending state. And then the node will sleep on its job for a little while and wait for the external adapter to come back again. And where's the external adapter going to come back again? It's going to come back to the response URL that you specify in your request to the external adapter, saying, hey, if you're doing a long-running task and you're telling me you're in a pending state, I'll wait, but come back to me on this URL. And that's what happens. So, the external adapter will come back on that URL, wake up the job, and then, the rest of the story gets processed. Okay, so let's get started with coding, because I do want to be able to answer questions. Before we jump on, head over to this the same GitHub repo that's showing on your screen at the bottom, right? Head on over there and let's do this together. Actually, I'm going to just clone this. So I'm going to do git clone, and what I'm going to do is I'm going to do git clone, and this can go straight into. Sorry, I'm just making sure that I've got all the stuff on my checklist here for you guys. So, yep, cool. All right. So I'm going to do the git clone. I'm going to do that, and I'm going to do a full stop so that I'm in a live code folder right now, and I want the files to be pulled down in there. I don't want a new folder created. So that's what happens. Oh, right here. Okay, so let me see. Oh, that's right. Okay, so let me just open. Okay, great. That may not be removed. Fine. Let me do this. I'm going to just do active demo and CD in there. Right, and then I'm just going to do git clone in here, and then we're going to do a dot at the end. Cool. Excellent. All right, so while it's doing that, I suggest you guys do that as well, and then I'm going to open this up. Okay, and so there you go. It's got the code. Now, hopefully you guys should be able to see my terminal. Let me know. I'm going to take this. Yeah, I'm going to take that off. Oh, maybe I'll leave it in there for a while, but hopefully you guys can see my screen. I've increased the size a lot. Like, it's huge in mine, and it seems just about okay on the live stream. So that should be okay. So as you can see, we're in the start here branch, right? We're in the start here branch. And I've already given you a basic contract, which we'll run through. I've given you the job spec, which we'll run through later on as well. But we're starting from scratch here. So the first thing we want to do, let me actually stop my there we go. I'm just going to remove my face shot so you guys are undistracted by. I'm not taking up screen space. Okay, so we've cloned it. Now the first thing we want to do is I've got a package.json in there, by the way. Just let me close that. I've got a package.json in there that has a bunch of your dev dependencies, including TypeScript, right? And I've got a basic start script. I use Nodemon so that the server restarts. This is going to be an Express application, so that's because it's basically server and we're doing it in JavaScript. We're basically doing an API, an HTTP API endpoint. We're using the Express.js framework, Axios to make the calls, .env to read environmental adapters, and then we are using a couple of, well, we may end up using this, we may not end up using it. But the good thing is because the package.json is ready, all we got to do is do a yarn install. And we're installing all the packages that you've got. So you guys don't need to worry about that. If you've cloned this, all you do is do the yarn install. And then let's get started. Actually, hang on. Before you get started, tsconfig. Let me show you what's happening here. Right, very basic because we're doing basic TypeScript, but it's going to be very basic for this. I just wanted to do it for showing you structuring. So when we run our server, it gets compiled to the out directory, being the dist directory, which doesn't show up yet. It'll show up once we actually compile our TypeScript code. So first thing I want to do is I want to create, now that I've done the yarn install, I want to create the Express app, right? And I'm going to first tell you which API we're calling from. Don't I need to do that? Okay, so we're going to call from the numbersapi.com. All right. It's just for illustration purposes. It's kind of quirky, but let's say what we're going to try and do is we're going to try and do numbers API. This is the API endpoint we're going to end up hitting, right? We're going to do numbers API. Let's say some random number, 77. Okay. If you guys think of a better number that you want to try and hit up, just put it in the chat, and we'll see what it says. And then for that, we want to get either a trivia fact or we want to get a math fact. Okay. Those are the kind of inputs we're going to do. So let's try trivia and see what happens. So if I hit numbersapi.com/77 trivia, it says 77 is the atomic number of iridium. Trivia, right? And you'll also notice it's not JSON. It's a string, right? It's just a string. There's no object in there. Let's try another number. Let's just try 92. There you go. 92 is the number of, let me try and zoom that in. 92 is the number of letters in the longest, wow, place name. I like that. That's a really, does anyone know where that's from? That's pretty cool. 92 is the number of letters in the longest place name. That's something else. Wow. Okay. So that's cool trivia. Let's see what happens if we do 92 and math. What math fact do we get for the number 92? It's the number of different arrangements of 8 non-attacking queens on an 8x8 chessboard. There you go. Who knew? Anyway, so the point is, we're going to be using this numbers API .com, and we're going to pass it a number, and we're going to pass it an info type, as I call it. We can also do this. We can also get the system to choose a random number. The API will choose a random number, and we'll say, give us a trivia piece on that random number. Well, here you go. 267,000 is the number of words in James Joyce's Ulysses. That's a long book. Okay, so that's the kind of API we're going to use. So getting back to the code, let's now create our server, right? So I'm going to create a new folder, the source folder, and then inside that, I'm going to create a new file, and I'm just going to call it server.ts, nothing fancy, something self-explanatory, and we can get started on coding that. So because we've done all our dependencies, I'm just going to close this out now, and I'm going to take that thing off the screen. There we go. Please let me know in the chat, guys, if you're not able to hear me properly, see me properly. Sometimes I've got a wired connection, but sometimes it can, because of the latency, the res can drop. It should come back up in a bit, but that's just the nature of live streaming. So I apologize if that does happen. Okay, so we're going to do an express server. So we'll have 2 endpoints. We'll have a get route just to make sure things are working, and we will have a post route as well, just to make sure it's working. And if you're wondering what we're going to be posting to it, if you go back to the repo, I've described the structure here. I've also said that the request data will end up looking like this, right? We'll end up the external adapter is expecting to look data in this shape, to receive data in this sort of shape. So the curl request is a little bit above there. You can see that there. That's the kind of curl request we'll end up sending, something similar. You'll see we give it an ID when we're curling. We just give it any ID we like. And the data, we're going to say there's going to be a number field, and well, it can be an actual number expressed as a string, or it can be the word random like we have here, right? So that's that bit. Or it could be an info type trivia, and the trivia can be the last bit in the path parameter there, right? Or it can be math as well. So that's a sort of post request. Okay, so let's get started on the code. What I'm going to do is I'm going to copy and paste some of the import statements because I want to not waste your time with that. Now, the first thing we're going to do is declare or give our input some sort of structure, because we're using TypeScript, right? So we might as well. So we know that we should ideally have an ID field over there, which is going to be of type number or string. We know that there's going to be a data property, which may be empty, right? But hopefully for our purposes, it won't, because we're trying to show what we're trying to do here. And this is going to be, it's going to have a number field, because that's one of the path parameters we're going to send. And it's going to be a number of string, because it could be a number, or it could end up being a string like random, right? Then we're going to have the info type, which is going to represent either math or trivia. And so this is just going to be a string, because it's going to be either math or trivia, really. Okay, and so we have the input. Now let's type our output. So what's the output data shape going to look like? Well, it's going to look a bit like this. We're going to have that job run ID thing that I talked about, because we want to be able to trace our request and our response all the way through the system. We should try and return a status code, because it can be useful for handling things on the other end. The data object is the result of our computation and our data fetching, and it's generally good practice for our data object when it's replying to back to the Chainlink node. It's good for the data object to have the actual result we want the node to pick up as a top line item, right? And that can be anything. It can be an object, it could be a string, it could be a Boolean. We don't really know, so we'll just type that as an any. And then there may be an error in some cases, and in which case we're going to send that back as a string. So this is what our let me close that up. This is what our output data looks like. Now, let's set up our basic server scaffolding stuff. So, here we go. let's set up the port. So we have process.inv.port 8080. And in case you're wondering about all the imports, well, we're importing Express itself, and then some of the types for the Express app, the request data object, the response data object. But this is Express's request and response, not our EA's external adapter's request and response. We need to pass JSON for the input, which will come in JSON, and then Axios for making the actual calls to the API. Right now, we create the app instance, which is going to be of type Express, and so we instantiate that like this. And then we say, well, we want to use JSON, so we're going to say app.use body parser. There we go, .json, and actually invoke the function. Now let's just set up a basic route, which is going to test that our server is even working, right? We basically got things up and running. So this is going to take in a request of some sort. Well, this request is going to be of type request. As you can see, I've imported at the top, and the response is going to be of type response, also imported at the top. And all we want to do is send back some confirmation. External adapter says yellow. All right. Now we need to actually start listening to the actual requests that come in. So we want to do an app.listen. Our server app is going to listen at the port, and when it gets a request, it's going to come back with a friendly message saying, awesome, server is listening on port, whatever the port number is. We're not going to actually set it in the environment variable. We're just going to go with the 8080 here. And I think that should be enough to get us started, right? Let's see, we've got the, yeah, I think that should be enough. Yep, that should, let's find out. I'm going to open that, and I'm going to just do a yarn start because I've already got the start script in the package.json, and that should work, right? So let's go to localhost 8080, and let's see what we've got. Woohoo! External adapter says yellow. Okay, so far so good. Thanks, guys. Thanks for confirming that. Welcome, Dev0x, and thanks for confirming that you can hear and see. Okay, that's important. So good. Here we go. We've got a basic adapter running. Okay. Now let's see what else we need to do. We need to do another app.post. So this is what our Chainlink node is going to end up sending our request to. So we prescribe the route, and we're going to say, okay, let's do some computation here. Okay, and I'm going to copy this request and response stuff because we're going to use it now. Ta-da! Okay, now this is where we're going to get the input. Okay, this is where we're going to get the input, and that's going to come. If for those of you familiar with Express servers, the JSON input is going to come to us in the rec.body property. Okay, so the request that comes in has a body property, and that's where our input is going to come in. So let's just say that. Let's just say, hey, constant, here's the input data, right? And it's going to be of the type EA input, which we've declared above here. We're expecting that type. So we're saying the input data is of that type, and it's going to be what's in request, our body. And next, we just want to, give us a happy message saying, yeah, I got something, request data received. And if I could spell receive correctly, and what's it going to be? It's going to be this bit here. So it's going to be the EA input data, right? Okay, so that way we can actually track in our console whether it's actually coming through or not. Now I want to start building the API request, right? Let's build the API request. Cool. Now let's go back and see if we want to make it look like this, right? Something like that, right? So we're going to say to look something like this. Okay, so let's start with that. So we want to try. So we know we need there's a basic URL that we can see over there, and I'm going to use the string interpolation. So we can say HTTP. Actually, let me just put it in like this. It'll be faster. Yep. Okay. And we know we want to replace random with the input that we're getting from EA input in the number, EA input data number. So we can change that here. We can just say this becomes, whoopsie, I caps locked myself. EA input. Yeah. And then if I, because we're using TypeScript, it tells me, there's data and that has a field of numbers. So let's do that. Okay, so that can be a number or the string random. And we're going to do the same thing for trivia, because it could be trivia, it could be math. So we want to do EA input dot data dot info type. Great. So now, depending on what we send through to a custom adapter, it's going to pull out the data we send through and build the URL that way, right? Now we need to build a response. Build the external adapter's response. Ooh, and that was a genuine accident. That wasn't or maybe it was a Freudian slip that I did build. Anywho, so let's build the response. And this is going to be of type EA output that we've declared at the top. We created this type here, right? Oops, that one. This. Okay, zoom in. There we go. That type. So this response is going to be of that type. And so it's going to have, and the cool thing is it's going to tell us, well, EA output has a data property, has an error property, it has a job run ID. So let's start with the data property. Okay. We know that at the very least that, it's going to be blank. We'll leave it blank for now. We'll populate it in a moment. We know we want a job run ID. Great. And that can be the EA inputs ID, right? Because we'll be sending some sort of ID. You'll see we some sort of ID will come in our curl request. We'll just do an ID of 10 or 1 or 3 or whatever random number we want, but we want to have that there for tracing. The job run ID will map to that, and we can do a status code. For now 0, not ideal, but it'll get us there. Okay, just that we don't have to type in extra code later on. And that's going to be a starting point. This is not the final response, guys. Okay, we're just building a variable called EA response to store the basic structure. And now we've got to actually hit the API, right? So I'm going to do a try catch, right? And in the try, I'm going to try and hit the, I'm going to try and get the await Axios .get the URL that we built up here on line 38. Okay, now I'm going to assign that to a variable called API response, because that's what it is. It's going to be of type Axios response, which I've already imported up the top, and that's where the result's going to be. Now, of course, it's complaining about the await. Why is that? Because I've not marked my post function as an async function. Go away, complaining ID squiggles. Voila, gone away, complaining ID squiggles. Okay, so we get the response. Now we want to start building this EA response object based on that, right? We'll handle the error in a moment, but first let's assume that we've got a successful happy path outcome. So what happens? Well, the EA response is going to have its data field look like this now. It's going to look like, remember, we want a top line result property, and that is going to be the actual result that we want our node to work with. And so that's going to be Axios returns the data on a data property, and we just assign that to result. Okay. And then we want to set the status code. So we want to do status code. I say status and status interchangeably. That's going to annoy some people, isn't it? I decided to change my pronunciation in the moment. I do that with data and data too, by the way. It's really weird. Like sometimes I'm like, what am I going to go with today? Status, data, data? Like, I don't know. It's always a surprise to me what ends up coming out of my mouth sometimes. Anywho, API response.data. Oh no, that's not right. That should be .status, shouldn't it? Yeah, right. And that's the status code. Now we want to send back the response. I mean, I suppose we could do it later, but I'm going to do it now because it's easy to forget. We could just do it a single time after the try catch. And I'm going to send back, this is the happy path. I'm going to send it back here. Now, technically, I could put this here after the catch, but you guys can do that. I just want to make this really clear and obvious for people who aren't too experienced with this stuff, right? So let me actually remove that for the moment. Now let's handle the error path, right? If there's an error, well, I'm going to say there was an API response error, and that's going to look like this. API response error, it's going to just be the error object that we got passed into the catch. Okay, now I want to try filling up the data or the response object, because that's going to start having, we need to show that it wasn't successful. So we'll put the error property on it, and that's going to be the message that comes attached to the error object. That's just how these things work. Now, this is going to complain in a moment, I think, because, yeah, there you go. It's saying type unknown. So in general, different IDs will suggest different things. You could just put Axios error in here, but sometimes it may complain. I just do any because I'm fairly confident I know what the error is going to come out. Like, I wouldn't necessarily do that when I'm testing it, but for now we'll just do that. And then we want to do the EA response dot status code is equal to the error dot response, because it'll have a response property and it'll have the status code on it, right? Actually, it'll have a status property on it, I think, from memory. Cool. So what happens here? We build the URL, we construct the basic shell of the response object, and then we hit the URL, right? We hit the URL, let me space that out, and then we populate that data shell, and then we send that out in a response. If things go wrong at this in this Axios request, we hit the catch block, we console.log the error, we fill up the error object, the response object, and then we want to try and send that at the bottom here. Okay, now, like I said, this line 59 and this line 53 could actually be at the very end of this handler here. I'm just putting it here so that, for those who are new, the logic is very, very obvious that we send the response depending on whether it's successful or whether we've caught an error. Now, hopefully, this should work. Let's bring up a console again. I'm going to restart that just for safety's sake, and I'm going to do that. Now we need to try and do a post request. Okay, so what I'm going to do is I'm going to create a new, I'm going to rename this one to server so we always know which one's which. And this one I'm going to do a curl request from. Now you remember that we can do the curl request from here, right? So I'm just going to try and copy that. It's a curl post type application JSON, sending it to 8080, and the data is going to be, we're going to give it a random ID of 10. Data is, we're going to look for the number 19, and the info type is going to be math. Let me hit that. There we go. We've got a result here. Now let me take a look at the server, because I should have console.log that as well. Okay, so this is what I've done incorrectly. I should be console logging my response as well. So I'm going to do that here, just so that's easy for you guys to follow, right? Console.log a returned response is the EA response object. Okay, so that's restarted. Let's go back to our curl, take some space, do that again. Same results come, and we'll study the result in a moment. Okay, so we saw that the request that we send, we asked for the number 19 and info type math, and it returned a response, and it put it in the data object, the top level result. That's the result that the server wanted. That's the result that came from here, from Numbers API, right? And then we have a job run ID, which is the same as the ID that we sent in, and the status code of 200. Great. Okay, so this means that our external adapter is now working. Now, this is a simple one just for you guys to understand the inputs and outputs, right? So it's nothing fancy, but it's working. That's good news. Now, let's just get back to this thing for a moment. Let me try and get back to this one, the architecture. You know what? I'll try and show you this architecture on the actual adapters repo, okay? Let me zoom in a bit for you guys. Okay, so we've just done the external adapter here, second from the left, okay? Now we need to try and deploy a consumer contract and set up the TOML job and all that, and I'll show you how to do that. But for that, remember I said you have to have the node, the Chainlink node running in the background, okay? So let's do the consumer contract now very quickly. The good thing is I have actually given you a basic consumer contract here in, where is it? In contracts. Let's open that up. And what I want you can go to docs.chain.link, right? You can go to EVM chains. You can go to connect to any API. Where is it? Here you go. Connect to any API, make a GET request. Choose any one of these. I would just go with a single, or you could do with an existing job request or one of these. And you'll see that the contract that I'm going to walk you through now is kind of similar to what's here. Okay, they're fairly well, they're not, I wouldn't say they're straightforward necessarily. If you haven't seen something, everything looks complicated. It's not as complicated as it looks. I'll walk you through it. But basically, the contract that I've given you here is a slight adaptation of this one. Okay, so let's walk through it. This is the contract that we're going to deploy. That's going to be the client or the consumer, and it's going to be the one. Thanks, our guy, our Rai guy. That's absolutely right. Dada when the server code works. Anywho, so this client contract here, let me get rid of that, is the one that's going to send our request through the Oracle smart contract. That then hits the node then triggers the job then speaks to the external adapter speaks to the API responds it, and all the way back. So you can just use the one I've got here. You can use it exactly as is. A couple of things for you to know. We're running on Gurley, okay? We're going to run on the Gurley network. We're going to store the string that we received. So, this string here, the response, for example, in this case, it would have been 19 is the maximum number to forward to the nth, whatever. That will be stored in the smart contract in storage, just so that we can see it later on. And it'll emit an event. That's fine. But what is it actually doing? We go past the constructor. It sets the Chainlink token. It's requesting info. So the request info function is the one we want to trigger. We give it the Oracle, the Oracle smart contract that's associated with our node. We give it that address. We give it a job ID. I'll explain this to you in a moment. And hey, we're seeing number and info type. So this is the data we pass in that will get populated in the URL. And then we build a request object here on line 38, right? Then we add the number property to that as kind of like a path parameter. Basically, we end up sending a map or an object, whatever you want to call it, which has the number and its value. We have info type and its value there, okay? And so our external adapter will look for number and info type and then pull out the values and use that here in the URL. Remember how we build it up here on line 38 with our input object. So that's coming in the request. We're adding it to the request and then we send it. Now we send the operator request to the Oracle that we pass it in. Now in this contract that I've given you in the repo, we're using build operator request and send operator request. It's a little bit different in these ones. It's build Chainlink request and send Chainlink request. You can use both. The build operator and send operator is the one we're slowly sort of transitioning to now. It's a little bit more powerful for something. So I've used that, but you can use both. If you see something else in the documentation, that's why you can use both. It's backward compatible. All right. What happens when we send that? Well, that goes all the way to our external adapter. If everything works well, it comes back and it hits this callback. And where are we talking about this callback? Well, here in line 40, when we're building the request, we say this dot fulfill request info, which is the callback method name, the function name, and we're saying that's the one we want to hit with our callback. So we're actually telling our node, when you come back to us with the response, hit this callback here, right? And then we emit the event, we save it to the storage variable, and off we go. I've also added some helper functions here for you guys because it's going to be useful. Wow, we are really going to be over time, I think. Anyhow, yeah, so I'm going to, yeah, I don't see how I'm going to finish this in 10 minutes, but let's see what we can do. So the helper functions, you can withdraw your link afterwards. You do need to fund this contract with link. So let's do that now. Let me open Remix and get you guys started on this. Okay, so Remix. It's kind of easy to do this from the browser. Just connect to your MetaMask. I'm going to create a new workspace. I'm going to create, I'm just going to say live demo. And I'm going to say, I'm actually going to choose a blank one. And off we go. Okay, I'm going to try. That should be fairly zoomed in for you guys anyway. All right, now I'm going to try and create a new, whoops. I'm going to try and create a new folder called contracts. And inside that, I'm going to create a new file called, client contract, or you can call it consumer contract, whatever you like, okay? Just take it from the repo and paste that in, right? It should compile just fine. There you go, it's compiling away. Now, what do we want to do? We want to make sure that we connect to Gurley. So make sure that your injected provider MetaMask, you've got Gurley going. Let me make sure that I've signed in. Yep, good. And we just want to be able to deploy this. That's pretty much all we need to do at this point in time is deploy it. So the key thing here is we end up building our request, right? We end up building our request and giving it the data we want. So I'm gonna deploy this. It doesn't take any input constructor parameters, so that's fine. I'm just going to deploy this. It's going to deploy to Gurley, and Bob's your uncle with that. And then we'll move over to the other stuff. let's make sure it deploys actually, because I now need to fund the contract. So while it's deploying, let me talk to you about funding. Because we are using decentralized nodes, obviously they need to be funded to run the compute. And so what we end up doing is we send our smart contract some link tokens. And then when we make the request, when we're actually doing this, send operator request, you see we're making an Oracle payment. Our contract will send some of its link token over to the Oracle to pay for its compute services and to fetch the data. Okay, so this seems to have been done. I've got my smart contract here at the bottom. It's been deployed. Great. Eventually, we're going to call the request info function. Good. Right now, if we go down and we say get a contract balance, if we just call that function, I put a helper function in there, you see it has 0 ETH and 0 link. Okay, so I'm going to copy my contract address for a moment. I'm going to go to MetaMask, and this is why we need the Gurley link. Remember, I'm going to send my smart contract, 5 link. Okay, we don't need that much. Each request will cost about, on Gurley, it'll cost about, just 1. So that should be fine. I'm just going to send it 5 because I can withdraw it later on anywhere. And once this transaction confirms, guys, we will be able to see that our contract balance has gone from 0 link. It'll go to 5 into 10 to the power of 18, right? Because it's denominated up to 18 decimals. Okay, can you guys hear me now? All right. I've switched mics, okay? I've switched mics. It's probably going to be less quality because I'm using my default mic now. on the MacBook. But can you let me know that you can still hear me? Okay, sorry about that, guys. No idea. My mic's working. It's connected. It's not mute. I've done that accidentally in the past, so I have no idea what happened. Anyway, not the end of the world. Thanks so much for letting me know, guys. Thank you. I appreciate it. I'm back. I'm back. Okay, let me recap. So we had sent the currency. We had sent link to that. Okay. When I go back, so this is my node UI. This is the node that's running on my local machine in a Docker container. This is the Chainlink node that I'm running locally. Like I said, you need to have this running for this to work. And I've linked to a previous talk in the README on where you can find that, right? Up here, I've said you can check out that live stream that I think Patrick did that earlier today. And you can go there to see how to set up your own node. Once you have it running, your node's running in a Docker container, and your node needs to now speak to your external adapter that's running here, right? It needs to speak to this little external adapter. So this external adapter is running on port 8080 because that's what we set it, but the node is running inside a Docker container. So if we say localhost, it's going to look for a localhost inside the Docker container and it's not going to find it. We need to tell the Docker container that's running our node to speak to our machine, the MacBook in my case. We need to tell the Docker on my MacBook to speak to my machine on its port. And so how Docker handles that, it says, you use this string instead of localhost. So instead of putting this string into our bridge, we put host.docker because our external adapter is not running inside Docker. It's just running natively on my MacBook. And so I need to tell Docker that when I connect you to 8080, connect to my MacBook, not to the Docker 8080. Okay, so that's how we create this bridge. Now it says successfully created EA bridge. Wonderful. Okay, so there we go. And that's the URL it's going to hit to. Hopefully you guys, let me know if that's not clear, guys. I am going to be moving a little fast because we're going to run out of time very soon. I mean, I'll keep going. I know I'll keep going. But yeah, I just see, hopefully this you guys will follow this bit. Okay, so we've created a bridge. Now we need to create something known as a job. A job is what runs on the Chainlink node and handles all the steps of processing data in and out. Okay, so let's see what that looks like. I've given you a job that you can connect, that you can, borrow straight away in the repo. A couple of things for you to know. You want to change the name. So I'm going to call this EA demo job. Okay. You want to change the name. You want to also make sure that you have, you can remove this line because the node will automatically populate in there, but this job ID becomes important when we make the request. I'm going to take that out for now because the node ID will populate it anywhere. The smart contract address for your Oracle. Remember, we talked about, hang on, where is it? There it is. We talked about, we deployed this client consumer contract, but there's an Oracle/operator contract associated with the node's job. That's what this is about. Okay, so I'm going to put mine in here. When you spin up your own node and you create your Oracle, you'll see that you'll have your own contract. This address comes in two places. It comes down here in the submit transaction step as well. So I'm just gonna, and I said that as well, update it here and in submit transaction. Okay, so let's update it here in submit transaction, and I'm going to remove that comment. And I think that, oh, there's one more thing. There's a fetch task, and I'll walk you through this in a moment. And it says type bridge, and the name is, I've given it numbers bridge at the moment, but really it should be this one. It should be that one, demo 1-bridge. Okay, is that the one we just created? I can't remember. No, I think we created EA bridge. Let's use EA bridge. EA bridge. Okay, so we put that in there. Now let's quickly walk through this. This is the job that tells the node, okay, pay attention to what's happening in the Oracle contract and start listening to its logs. When you receive a log, when you pick up on a log and you listen to it, start working out what its data is, right? And then you decode that data if it's the kind of request we're looking for. Then using that decoded data, we fetch from the bridge. Now, guys, this is the kind of thing that you'll need to spend some time on the documentation to fully absorb. Just think about this. It's a series of steps, okay? One of them is the fetch step, which says from our bridge called EA bridge, get the data in this form, send it the request. Now, this form is going to look familiar to you. It's got an ID property, it's got a data property, and inside the data property, it's got a number and an info type. We know that. That's how our external adapter expects inputs, right? So we're sending it the input. Then we tell it, all right, parse the result that you get from this fetch step along the path of data.result. Remember, our result here, our return response has a data.result path to get to the actual data we want. That's all we're saying here. We're saying parse the data you get back from the fetch request, and along this path, data.result. We separated by commas, not dots though. Then we encode the data using ETH API encode, and then we encode the entire transaction, and we send it back to our Oracle request, which to its callback. That will then send the data back to our smart contract, okay? And the pipeline that we create is using these connected arrows. So the STOML specification has to have these connected arrows as well, okay? So it shows this is the sequence of the pipeline. This thing's output becomes this thing's input, okay? Decode CBOR's output becomes fetch's input. Fetch's output becomes parse's input, and so on and so forth. And so that's how we do this. So let's copy this, okay? We go to the job, and we will paste it in here. I'm just blocking that user because, oh well, apparently I can't block it. Maybe I can block this one. Interesting chats. Anyway, let's go back to jobs. We're going to create a new job. For some reason, it seems to do the old one over there. So we create a new one like this. We just paste in all that we talked about. EA demo job. And yep, we want to make sure that the fetch data is EA bridge. That's fine. And let's just create this. Okay, and you'll see that what it does on the right is it gives you all the steps. You can hover over these little nodes and you'll see all the steps. You'll see the type, you'll see the name, you'll see the kind of data that's coming. Thank you, Darv. Thanks, mate. Elbow is right. Let's just run that. Let's see if this works. Okay, so it says successfully created job 17. And if I go to the jobs, I'll see it was created just now. Now, this external job ID is going to get important in a second, okay? So let's go back to our remix and let's see. We want to call this stuff. We've got funding in the contract. We want to request info. We need to give it the Oracle address. The Oracle address is the same one that I talked about here, right? That we gave in our terminal specification. It's not this contract. It's not this contract that we deploy. This is the client contract. The Oracle contract is associated with your node. So let's put that address in there. The job ID. Remember I said we're going to come back to this. So we created this job 1 minute ago. I'm going to copy this ID and I'm going to put it in here and remove the dashes. Very important, guys. We cannot have dashes in the job ID when we're sending it from our smart contract. Okay, it needs to be a string without the dashes. So let's make sure that we have no dashes. Yep, looks good, right? No dashes. Anyone seeing any dashes? I'm not seeing any dashes. Okay. Now, what number do we want? Well, you know what? Let's just do random. Okay, let's see. Let the system pick random. Oh, let's do 92. Remember, that was pretty cool. It had the longest city name, I think, didn't it? So let's see, 92 trivia. Yeah, the longest city name. Let's do that one because that's kind of fun. And we want trivia. Okay, so just to recap, we're saying give us 92. Give us trivia about 92. And that's how we're populating our request here. So our Oracle smart contract associated with our node, the job ID that's going to process this request, the number that we're asking for, and the type of data that we're transferring for. Now, when I hit transact, MetaMask is going to open up and it's going to make me pay the link to the smart contract. It's going to go there. And what I'm expecting to happen, guys, what I'm expecting to happen is once the transaction is completed, first thing I'm going to expect is to see something here. So you know what? Let me bring this up here because my external adapter is still running. I'm going to clear the screen. I'm going to expect to see, the console.log that the input is received. I'm going to expect to see a console.log that the output is generated, all according to a server code. And then that data is going to go through into my node, and I'm going to expect to see in runs. These were test ones I did yesterday, 14 hours ago. I'm going to expect to see a new one. I will see it in a funny status for a moment, but we'll talk about that in a moment. And once this run is done, that is, once the job, the EA demo job, has finished its run, I'm going to expect the last retrieved data to no longer be an empty string. Right now, it's an empty string, right? Just in case you missed that, I'm going to click the last retrieved data, which is what we're storing it to. Remember, we're storing, last retrieved info. We're storing the information we get back from our node in last retrieved info. If I call it, It's an empty string right now. So, whoo, moment of truth, people. Let's do this. This is the hard part about live coding, I've got to tell you. It's always nerve-wracking, right? Even if you've done it like 100 times before, you never actually know whether it's going to work or not. So I've submitted the transaction with all this data, and it's calling. It's saying request info pending. First thing it's going to take a few seconds. Okay, it's going to take a few seconds, and then hopefully I'm going to see the request come through in the console if everything's gone out. Okay, so it's gone through. Let's see what Etherscan's saying. It's still indexing, so very, very early days yet. You guys can still hear me, right? No panic stations required. I know that the data is going to be, the sound's going to be a bit annoying because you'll hear me type and all that rubbish now because my mic's decided to take a walk, I think. Can you guys let me know if you can still hear me okay? Just drop it in the chat. Awesome. Thanks, Rahul. Thank you, man. Okay, so I sent a transaction. What is my contract's address again? 0xb2a. So that looks right. So I sent a transaction to my contract. It's transferred one link to my to my Oracle smart contract that sits with my node, and hopefully we'll see results fairly soon. Now let's take a look at this. Yes, look at that. Okay, so this is a very exciting moment for me, guys. No matter what happens, okay. We received data in our external adapter. It was given an ID. The request said, well, this is the callback, etc. Blah 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 blah. It's all got all kinds of encoded data in there, right? But the data property that our external adapter is going to be looking for is it's going to say, hey, great, we got an object with info type and number 92, and our external adapter has returned a response. Oh, I got a new trivia fact. I didn't get the longest city. Rats. Anyway, the new trivia fact is that 92 is the number of pounds of sugar in the average American. Whoa, I think I may have preferred knowing about the city. This is a bit depressing. Anyway, so we know that's gone back. Let's see what's happening in the operator UI. I'm going to go back to jobs, going to go back to runs, refresh. Okay, good. Now remember I said it's going to look like it's in a funny state. Suspended is fine. Okay, as long as it's not errored, we're okay. Let's take a quick walkthrough. Our node got the decode log, and you can see it got a bunch of requests from our Oracle node, from our Oracle smart contract. It decoded that, and it pulled out the data object, right, with the info type and the number property. Great. Then it said, let's send that data to our bridge, which it did. It sent it to the EA bridge, and it sent it in this data format, which is exactly the structure we wanted it to send it in. And it got a result along the data/result path, right? And you can see that's the result. Then it passed that, again, according to the data.result path, passed it into the string we want, encoded it, sent it back. Okay, moment of truth. I'm going to click on last retrieved info. All right. And it should, this zero string, this empty string, should change to that depressing fact about sugar. Come on. Yes! Yes! Oh my God, yes. Like, so happy right now. So happy right now. I'm so glad it worked. All right, guys, that was quite a lot to cover, but let's just summarize what we've done, okay? We built an external adapter. We did it in Node TypeScript. You can do it in any language you like, as long as it returns response that's structured in the way we structured it. We deployed a client contract that makes a request to our Oracle smart contract that then passes that request on to a node. The node is running a job that's specifically designed to understand requests coming from that contract. That job sends the typed request over to our beloved external adapter that we wrote. Our external adapter fetches the data from the API. We didn't do any heavy compute, but you can imagine that we could do stuff here. We could write to a database, add stuff from a database. We could do all kinds of heavy computations, and we can send that data back in the expected form back to our node. Yeah, good question. So that's just the way it'll resolve, Rocher. It'll resolve, right? So at some point in time, you'll see that my runs become completed. Yeah, the node just takes time to resolve. So that's just a laggy, you know how things are with the blockchain things have a bit of latency. So it will resolve eventually. You'll see the ones that I did yesterday show us completed. As long as you have green ticks all the way through, you're fine. You're absolutely fine. Okay. So So then the data comes back from the external adapter and goes all the way back into our contract. Okay, that's quite a lot to achieve, guys. That's quite a lot to achieve. So let's go back to this. We've done that. Now I want to tell you about market.link. In fact, I'm going to open it up for you. Okay, if you go to market.link, this is quite cool because what happens is node operators, people who run decentralized nodes, they provide a lot of services and a lot of data services for you, like data feeds using off-chain reporting. There are a whole bunch of other feeds, whether it's pricing data, asset data, gaming data, etc. In fact, why don't we look at an example of gaming data? We can, if you go, you can see price feeds, or you can see, I will just go to nodes and I'm going to say, maybe some sort of sports data rather than gaming data. I'm going to go to sports data IO, right? These guys will get, so that it's a node group. They're running a bunch of nodes. There's a bunch of documentation that connects to Chainlink documentation as well. These are third-party partners that run nodes, but they make data available, right? And they say, okay, you can use this Oracle, you can consume data from it. This is the client contract that we wrote, guys. Fund it with Link, call your request method, and they give you some suggestions. They give you the token addresses, sorry, the token addresses and the Oracle addresses. So these are third-party providers that run decentralized nodes that help you. They have custom adapters, and they will respond data. They will give you data, so you don't need to write your own for all cases. So this marketplace is a place where you can write your own external adapters. As long as they're thoroughly tested, production grade, you can actually publish them on this, right? You can get on market.link if you like. And they give you data. So if somebody else has data or an external adapter that returns the data you want, you don't need to write your own. They've got it heavily documented here. We'll take a look at the adapter code in a moment very quickly, but you can see that they give you the inputs and outputs as well. This is the kind of inputs their external adapter is expecting. This is the kind of outputs it's expecting here. They're giving you an example client contract, and you'll see it's similar. It has a request, thing that goes, where is it? It's somewhere here. It's yep, there's the callback, and then they build a bunch of the requests. There's a cancel request, and then the request schedule says build Chainlink request, build Chainlink request. So there are different types of requests and responses that you can get out of the one adapter, right? Because it's able to do all that heavy compute. And they've got a job sitting on their Chainlink node that will respond to this. Now, taking a look at their adapter code, you'll see that if you were to go to source and go to, I'm guessing, index, maybe this is where it all starts, but you'll see it's more sophisticated than the one we wrote, because obviously it's able to handle retries and sort of failures better and things like that. And they also use this Chainlink EA Bootstrap package, which is like a framework for building external adapters, which you can also check out by all means. If you go back to our repo for this code along, we have now written the server. So we've basically done what branch 2 has. But if you take a look at the advanced EA server, you'll see that has a lot more sort of advanced looking stuff, right? It's got validation, for example. Oh, this is the actual router. Sorry, here you go. So you'll see that it imports this adapter package that I think Darb had referred to previously in the chat. And you'll see that it does a lot more complex handling. It does a bunch of validation if you want. It forces data to be in a certain shape on the return. You can handle authorization and headers. So you can always refer to this. It's a lot more detailed, a little bit harder to follow in a 1 hour code long. So that's why I didn't follow this. And you'll see that it also does exports GCP service or exports handlers. Remember how I said that your external adapter can run as a cloud function or a Lambda function, a cold start Lambda server. That's what that's what these little exports are for. So you can export your external adapter to respond from a cloud function. A couple of questions here. Thank you for putting that, Dub. We can use Oracle to test own adapters. No, because you need to remember how you need to add this job. You could always speak to them and ask them if you can add a job to their adapter. You'll have to test your external adapter against a node where you can actually create a new job or give them the job to put, but it's easier if you run your own so you can test it faster. But ideally, you'd want to have your own node running if you're going to create your own adapter. That's probably the smoothest part. Unless somebody is running a node, you can give them the job, the actual definition, the STOML stuff. You can give it to them if they're running their node and have them configure both the job and the bridge. You got to configure that, and then you give them your URL for your external adapter. In theory, you could do that, Rocio, but probably not the easiest path. All right, guys, let me try and conclude because we are 15 minutes over. So I do apologize for that. Please, 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 please. I need to get better so that I can serve you guys better. I cannot tell you how passionate I am about this space. I really want all of you to succeed. I want to take away as much friction as I can. Let me know. I know I went a little bit over, but let me know whether I managed to convey what I needed to convey. Let me know what you're thinking about the hackathon. Let me know anything you want. All feedback is welcome. My goal is to get better so you guys can get a million times better fast. Okay, that's my goal. In terms of getting help, there's the Discord chat, there's the hackathon resources on Stack Overflow. Just tag it with Chainlink, and of course, there's that documentation as well. We're a little bit over time, so hopefully I've answered most of your questions that you guys have put in there. And again, the feedback form QR code is up there. Please, please, please take a moment, zap it on your phone, and leave me some feedback. The last hackathon, I got some really good feedback, and I was able to incorporate that in this presentation as well. Thank you again for being here. I appreciate your time. I appreciate your interest in the space. And most of all, I'm appreciating the effort that all of you guys are putting into moving Web3 and decentralization forward. Thank you so much for being a part of this movement that's so important to all of us. All right, guys, have a wonderful, wonderful rest of the day. And in case you do want to reach me, Twitter is good. Twitter is good. And at Dubin Pratap, you can reach me there. But definitely try and leave some feedback as well. And I'll be interacting with you guys online, I'm sure. Thanks again for joining, guys. Yep, that's right, Dub. Just to say, external adapter video from Harry does point to a video game API. So you can point to any API you like, and that's kind of the fun of it. So thanks for putting that link in there on the chat. Also, I've linked to some other stuff in the repo as well, so that should help. Cool. Thanks very much, guys. Take care.